All right, let's begin recording, watching 4-1, day 2, pre-calc. That's to be found on page 113 there. And there's a lot of information. So day 2, really going to pile on day 1, but it's also going to have some new information. And I'm going to try to just scratch the surface of all these new ideas and then tie it all together on your packet lesson where I actually do these sample problems for you, okay? That's my plan. So, first of all, let's get started. You're going to see this phrase, unit vector, and that's any vector with length 1. Now, as a math student, it's interesting because you listen to everything a teacher talks about and you think you're responsible for everything, and that's true. But there's also like levels of importance. And I will say, yeah, you need to be aware of what a unit vector is, and there's a formula that's going to help you find a unit vector. In other words, if any vector has a length other than 1, this formula will find it. It will manipulate the original vector so that it will have length 1, magnitude 1. Now, what's the use of that? In our class, you're going to see a few practice exercises, and we're not going to use it too much. Now, when you hit calculus, there's going to be a benefit from dealing with converting these long or strange decimal vectors into a unit vector with length 1. But for now, it's just an exercise and an introduction to you to a new phrase. Now, when we get to here, this is where the real trig hits. So just keep that in mind as we go forward. So a unit vector is any vector with length 1. Therefore, the magnitude, that's what this absolute value stuff looks like, of any unit vector, I could put a V in there to stand for V, victory, or vector, is 1. All right, don't want to keep hitting that dead horse. So next, to find a unit vector of any vector length, AB, it can be found by just using this formula. Now, let's go ahead and put in a sample problem like 2, 3, okay? So obviously, if I was to draw this, because of these little pointy things instead of parentheses, that means it's a vector with an origin at the origin, and in other words, it originates from the origin and it goes to 2, 3, and there it is. Now, obviously, this is 2 and this is 3. So a squared plus b squared equals c squared. That's 9 plus 4, which is 13. So we know that the magnitude is the square root of 13. Therefore, this is considered not to be a unit vector. Well, how do we convert this to being a unit vector? Right here. You would simply take this formula. A is here, A, B is here, B, just goes in alphabetical order. And then you just divide those original pieces of information by the magnitude. So I would say, all right, so that'd be 2 over the square root of 13, comma, 3 over the square root of 13. And there we have our unit vector. Now, if you're like, well, wait a minute, prove that to me. I could do that quickly. But I'm just going to go 2 square root of 13, and then I'm going to go 3 square root of 13. And we're going to use Pythagorean theorem. So we're going to square this, and we're going to add it to this square, and we're going to hopefully say that, that this equals 1 here. Oh, I messed up. Well, I'm glad I caught that. 2 over the square root of 13. 3 over the square root of 13. Wow, that would have been catastrophic. Anyways, so this would be 9 thirteenths. This would be 4 thirteenths. What's 9 thirteenths plus 4 thirteenths? 13 thirteenths, which equals 1. So really I'd get c squared equals 1, take the square root, and now I'd say, aha, this magnitude is 1. You see, it's a formula that works. It just works. And there it is. How often are you going to use this in this class? Not very often, just being honest with you. But you're going to be responsible for it on the Unit 1 quiz, or excuse me, what are we in? Unit 4, okay. Unit 4 quiz. Now, look at this. The letter I so we're done with that. The letter I is going to show up, and that's a unit vector that's 1, 0. The letter J shows up. and that's a unit vector that's 0, 1. So when you get this weird looking stuff, it's really saying this. And I want to show you something. Then we learned in the previous section that you can distribute that through, so that would be the same thing as 3, 0 plus, distribute, I'd get 0, 2. And if I added these together, I'd get 3, 2. Now look, after you've done 10,000 of these strange problems, you're going to go, wait a minute, if I just put the 3 here and I just put the 2 here, does that work every time? Yes. So the letter I, when they sneak it in on you, and the letter J, when they sneak it in on you, I mean, it's not that big of a deal. So you just deal with it, and you write the actual component vector there, and you move on with any other question they have for you. Okay. Now, again, these are just introductory ideas. It'll make more sense when I hammer out some sample problems. This is what I would consider the meat and potatoes of this whole lesson, this formula. Now, this is the way that it's given to you on the back of page, well, on page 114, okay? At the top there. It's given to you just like this. And I think it would be better off if it was given to you like this, written in the red, where they actually have a vector written in component form there. Because this is in the same position as this. This is in the same position as this. And what I'm saying is, look at the parts. This is just the A, whatever comes first. This is the B, whatever comes second in this component vector. And notice this is going to equal the magnitude of the vector, of this vector, times cosine of the angle. What do you mean the angle? Well, like for this problem, it would be this angle. It'd be that little reference angle right there. It's how far you had to spin the spinner to get that angle. And then, but this piece, B, would equal this piece, which is the magnitude of this entire vector times the sine of that spinner angle. All right. Now, I'm not going to finish this problem for you because we are running out of time a little bit, and I think you're just going to get the gist. But they're going to give you a problem like this, and they're going to say, hey, find the angle. They're going to say, find this. And they're going to also say, find the magnitude. Well, the magnitude is super easy. You don't need to draw a picture, but I think it would help you. So -1, 2. And that means my spinner or my vector is right here. So if I want to find the magnitude, it's just a squared plus b squared equals c squared. That's 4 plus 1 is 5. So I take the square root, and I get the square root of 5. Now, I know that this is now the square root of 5, and I know that this is the square root of 5. So those two things are the same because it's just representation of the magnitude of the vector. Now, what is this? Well, in the picture, it's actually this. Now, I'm going to show you guys something. This is very unique. Now, I'm going to write cosine of theta, because that's what comes along for the ride, and I'm going to write sine of theta. Now, what did I say? And I put great emphasis on it. A, that spot, equals that spot. B, in other words, that spot equals that spot. Very, very unique thing in math. I can do one of two things. I can say this stuff equals this stuff, so -1 equals 5 times cosine theta, or I could say this stuff equals this stuff. And I should have the abilities now to get home from there, but you're going to need one of these wonderful calculators. So watch this. So if I said, hey, divide by 5, I'd get cosine of some angle equals negative, now I'm going to convert that to a decimal, 0.2. Now, how do I get from something like this to actually finding out what this degree measure is? This is where we go second cosine. So we got to take our second button, cosine. Now we're going to hit, what do we have there? -0.2, enter. And I don't have my glasses, but 101.5. So this says 101.5. Now look, does that kind of fit? Does that look like it's possible? Yes, yes. However, what if a second student went over here and said, I want to solve this one? Well, then they'd get sine of theta equals, oh, I screwed up. I screwed up. I screwed up. How much time do I have? All right, 10 minutes. Did anybody notice that? This is not 5. It's the square root of 5. So, boy, I was fooled by that 101. That sure looked right. So what we would get is -1 divided by, all right. Oh, my glasses. Sorry, you guys. Okay. There, I found it. I found it. -0.447. So I get -0.447. There we go. So now I have to go second cosine -0.447. All right. I don't know how I got so close doing it wrong, but this is 116.5. There's a math teacher making a mistake right before your very eyes. This one, this cancels. How do I figure out what that is? Well, you just have to go 2 divided by the square root of 5, and I get 0.89. Now, here was the point I wanted to make. Watch what happens here. Now I'm going to go second sine 0.89, enter, and I get 62.87. Now, here's the thing, you guys. This is slightly rounded, but you're going to say, hey, you must have done something wrong. No. In this problem, this is telling you what theta is, but this one told me what this was. This one told me what this was, this little reference angle, so 62.87. So if I went this route, and I found this answer and I drew my picture, I'd have to subtract this from 180 to figure out what the real answer is. So the hint I'm trying to give you, and I'm running out of time, is notice how we had a negative possibility and a positive possibility? I would pick the negative one because that one's going to tell you the whole story first step. But if you pick the positive one, your calculator does not know what quadrant your drawing's in, so it will spit out one of these angles, but you have to have the picture drawn to understand what it is the calculator spit out to you in this particular moment. That's a lot of information, but hopefully I'll iron out some wrinkles on the packet lesson.